Welcome to week 4. This week will be online only, so please review this video and then you can work on your registry data model, which will be your assignment. So this week we're going to do an introduction to data modeling. These are the learning objectives for this week. You should be able to describe the process of data modeling, define cardinality, integrity, and constraint, and understand how business rules play a role in database modeling. Data models. So typically there are at least 2 and sometimes 3 data models that are done before a database is created. The first one would be a conceptual data model. And if we think about conceptual, we think about very high level, broad terms, what types of data would be needed for this project, where it would come from, and what the relationships would be. The next type of data model would be a logical data model, very similar to an entity relationship diagram, and then a physical data model, which has to be perfect because that is what defines the structure of the database. Sometimes the logical and the physical will really just be done as one, and other times the conceptual and the logical will be done as one. What we're going to work on this week will be conceptual, and you may have some items from a logical data model included with yours. At a minimum, a conceptual data model should include the entity names and the entity relationships. You can also put in some key or major attributes. You could define primary keys. You probably will not need to add any foreign keys or define the table or column names or the column data types. And we can see that the complexity increases from a conceptual to a logical to a physical data model. This is why we always start with the conceptual data model, so we understand at a high level what are all the different entities in our data and how do they relate to one another. Then we move on to the logical data model if we were actually completing a full database project in the workplace, so that we understand the details of our data without worrying about how they will actually be implemented. And finally, the physical data model, so we know exactly how to implement our data model in the database platform of choice. In a data warehousing project, sometimes the conceptual and the logical model are considered as one single deliverable. So this is just one example of what a conceptual data model looks like. Sometimes you will see this having oval shapes instead of rectangular shapes. The lines showing the relationships don't always have to have a dot at the end. This is just one example, and you can actually go out and Google on Google Images conceptual data model, and you'll see many different variations of this. So a conceptual data model identifies the highest level relationships between the different entities. Features of conceptual data model include the important entities and the relationships among them. Attributes do not need to be specified, but sometimes they are. The primary key doesn't need to be specified, but sometimes it is. And so if we look at this example, we have entities like time, product, sales, and store. You could think about this in terms of patient as an entity, claim as an entity, visit type as an entity, condition as an entity, lab as an entity. So moving forward with data modeling, this is extremely important. You never want to just go ahead and start creating a database. The same thing would happen if you just started to build a house and didn't go through the design phase with an architect and creating a layout. So with data modeling, we also have what's called the entity, attribute, and relationship diagram, which is more detailed than what you'll need to do for the assignment this week. A new concept to think about is cardinality. So this defines the different types of relationships. You could have a one-to-many relationship. Many times that's noted as 1:m. So think about this example. A painter creates many different paintings, but each painting can only be painted by one painter. So the painter is the one, and it's related to the paintings, which are many. And that's where we get a one-to-many relationship. Then we could have a many-to-many relationship, which is notated as M:(n). In one example, an employee could learn many different job skills, and each job skill can be learned by many different employees. So this is where we would specify this relationship as many-to-many. And then we can have one-to-one. A retail company's management structure may require that each of its stores be managed by a single employee. So in turn, each store manager who is an employee manages only one single store. So this would be notated as 1:1. Integrity and constraints. So this is defined as a restriction that's placed on the data. Constraints are important because they help to ensure data integrity. Think about your bank or your banking account. There is a constraint on that account so that money from somebody else doesn't accidentally go into your account, or money from your account doesn't accidentally get withdrawn by somebody else's ATM card. And integrity is making sure that the data is in good standing. You know, the last thing you would want to happen with your bank account is for that money to be sitting there and there be a loss of integrity where nobody knows who owns that bank account. Business rules. These are derived from a detailed description of an organization's operations that help to create and enforce actions. So one example would be a business rule for a university may say that a valid GPA can only be between 0 and 4. Or for, we'll say, an online store, when someone is entering an address, including where the country is the USA, that the states can only be one of the 50 states plus our territories on the drop-down list. And naming conventions. Entity names should be descriptive of the objects in the business environment and use terminology that is familiar to the users. An attribute name should also be descriptive of the data represented. We typically capitalize table names and column names. We make them short, and we use them in singular terms. So we do not have a patients table, we have a patient table. This is something that I just want to expose you to, but you definitely do not need to know the details on this. These are just examples of different notation methodologies that can be used when creating more advanced data models. Chen is a pretty popular one, so is the crow's foot. And this helps people look at these diagrams and be able to tell what type of cardinality is associated to these entities. Is it one-to-one? Is it one-to-many? Is it many-to-many? So key concepts that you should be aware of. Why are data models important? What are the different types of data models? What is an entity, attribute, and relationship? An entity is something that will typically turn into one or more tables. So just because you have an entity of patient does not mean that you're going to have just one table called patient. You could end up with a patient table, but then you could also have a patient address table for the addresses of the patient. You could have an encounter table that has all of the information about the encounters, such as clinic visits, blood draws, and tests that the patient has gone through. And then attributes are what typically end up being columns or fields in the tables. So if we're talking about a demographics table for patients, some examples of attributes could be first name, middle name, last name, street address, city, zip, date of birth. And then the relationship is what the relationship is between the different entities. So if we think about a patient and a medical claim, a patient has one or more claims. If we think about the relationship between a patient from one of the patient tables and their bill in the revenue table, a patient has one or more bills from an inpatient stay or an outpatient encounter. Cardinality is what we said describes the relationships. Is it one-to-one? So think about things like you can't split somebody. So you can't have something where you have a many-to-many relationship if people are involved. Typically, one person will say, let's say they're using a website to order books. One person can place many orders, but each order can only relate back to one person. One person can have an inpatient hospital stay, but there are many inpatient hospital stays within a hospital. Integrity, so making sure that data is not lost and it's accurate within a database, and this is based off of the business rules. And then constraints, making sure that bad data is not entered into the database and that the design does not allow for bad data to be entered. And business rules are rules that come from the business. So if the business says somebody has to have a username and log on to get in, that's a business rule. If the business rule says only ICD-10 codes can be entered into a certain field, that's a business rule. And the naming conventions, again, singular use, capitalized. Sometimes people will put some type of descriptor in the name. So if it's a table, TBL will be in part of the name. Model notations, so either crow's feet or Chen are the big ones. Understanding that big data is data that is large, has a lot of volume to it, it needs a lot of speed, takes up a lot of processing time, and then also NoSQL, which are databases that are not relational databases. They're databases where we can use data that is from graphs or genomics, images, or something called data lakes. So NoSQL are usually databases that have unstructured data as compared to structured data, which is what we typically find with administrative, financial, and basic clinical data that's in the EMR. ANSI is the American National Standards Institute, responsible for making sure that we have standards for different types of file systems, and ASCII for making sure that only certain characters are allowed in certain files, making sure that if you have a comma-separated value file, it's developed the same way if you use Excel to open it as if you use SQL Workbench to open it. It's a standard data file type. And then just be aware of the conceptual versus the physical data models. So the lab activity, which is due by Friday, February 15th, develop a conceptual data model for the following scenario using either Microsoft Word or PowerPoint. So the scenario is that a group of advocates for suicide prevention want to develop a registry that contains resources for suicide prevention. So think of this registry as a small database. And things to consider, there are different resource types. There are phone lines that people can call in, social media campaigns, brochures, posters, websites, community centers. There's talks that people give. There's many different types of resources, more than what I have listed here. And there's also different populations that may or may not be more at risk than others, such as youth, LGBTQ, disaster survivors, veterans, and other types of populations. And what you're going to do is draw out a conceptual data model. At a minimum, it should have the entities and the relationships. And then you can submit this file to Canvas.